Coming back to the agenda, what's on the list for today? I'm going to show you the new component and accessories. It's about meters, inverters and smart energy devices. And in the second part we're going to talk about new functions implemented with the new firmware, such as the part of definition and recognition of devices was completely reworked. In the feed-in management there's a new function, and then this is the major part of the webinar, the smart energy, and I'm going to show you some new functions and some application examples. New components. With the new firmware there are new inverters implemented, such as the SMA STP60, which has a wide use, especially in Asia and in bigger plants. So I think this inverter helps to get more plants on SolarLog. Then we have the Canadian Solar as the 100th manufacturer we implemented into the SolarLog. And the Costal Pico MP series devices have also been implemented on the protocol level. In the area of meters, you all might know the SolarLog Pro 380 meter. This one is to measure up to 100 amps, and now there's a new version available. It's the SolarLog Pro 380 CT with current transformers. So this meter has the same features like MID, bidirectional mode, and the energy flow can also be detected with the CTs. You can get some transformer sets also from us. There are different types of transformers. I'm going to show you some of them now. Here you can see the Pro 380 CT meter. This is the top side where you have the connection for the CTs, one side of the CTs. Here you have the connection to Modbus and to S0 out. On the bottom side there's the other connection for the CTs and for the voltage. So the CTs are connected here power-wise, L1, L2 and so on, and the voltage measurement is just here directly on 230 volt level. This can be combined with the CTs. As I told you, there are different types of CTs, different sizes. This, for example, is one. You can open it and then you can put it on an existing cable. This one is an example for one you cannot open. You just have to put the cable through the hole. So you have to open the installation. If you do the installation new, it will be the same. And here you can see a third version. This is also one CT you can open. You can click it around the cable to measure. Which CTs you need depends on first on the size of the plant, on the amperes which are running through the CTs, and on the other side of the occurrence if you need for billing purposes or if you need for monitoring purposes. There are different classes available of these CTs. But you can also use your standard CTs you used before. We suggest a secondary ampere of 5 or 1 ampere secondary output of the CTs. We have also other meters available for the international markets. There's a Schneider meter for the Indian market and Elcor meter for the US market. I can show you also the Schneider meter. This is for installing in cupboards, and the connection is on the back side. This is the device. The Elcor is only used in the US, so we don't have any of these devices here in Germany. It was implemented by the colleagues over there. Another new component, the EGO Smart Heater. It's now available in an Ethernet version. You might know this device. It was available in a RS485 version before. Now you can connect it directly over Ethernet. The heating power is the same like it was before, from 0 to 3000 watts, switchable in 500 watt steps. But what's new now, you can connect up to 6 heaters to one solar lock, and they are now cascadable and can be priorized. And you can also mix it up. If you already have one of the RS485 version, you can add 5 Ethernet versions to one solar lock. And it's not only the new hardware with the new connection option, it's also a new functionality. It's now possible that you configure a minimum temperature in degrees centigrade. You can see it here. And you can activate it or deactivate this function. And if this temperature you configured here is reached, the EGO starts automatically to heat the water up plus 7 degrees centigrade. So in this example, he will heat up from 40 to 47 degrees. In any case, so you don't care if it's PV energy or grid power, he does this function. You can choose the heating power he will use to heat up 47 degrees, so you can choose between 500 and 3500 watts. In the area of smart energy actuators, there are also new devices available now. This is the Gude 2110 and the Gude 2104. I can show you these devices also in live. So this is the Gude 2110. It's a metal case, very solid. It comes up with 4 relays for close or to make contacts, and it's connected on Ethernet to the solar lock. For the future, there are also 2 sensor inputs and 4 digital inputs. This will be implemented in one of the next firmwares. And the second device, it's very small. It's called Gude 2104, also connected on network. And on the other side you have the power supply 12 volt, which is included in delivery, and the change contact relay. So this is maybe a solution for people who have a SolarLock 300 or maybe the older generation SolarLock 200 or 500, which hasn't the internal relay like the 1200 or the 2000. Then this could be maybe an alternative to do some smart energy things. But these 2 actuators are not available via our company. You have to get them on the market or directly from the manufacturer Gude. In the area of smart energy, there are also some new functionalities. In the visualization on the TFT display of the solar locks, you can now see the energy flow, and you can choose for the slideshow with which screen the shows should start and after what time the screens should be changed. To come to the power management, As I told you, there's a new active power regulation functionality. It's called fixed regulation in watt. This is not the same like the fixed regulation in percent. What does this function do? It's used for hybrid plants mostly. The idea came from the UK market. So there are a lot of installations where they have combined plants with wind and PV. And they have a maximum feed-in possibility of like 5,000 watt in this example. So what does the solar log do? He has two generators. One is the unregulated generator like the wind, and there's another generator, the PV generator. This one can be regulated by the solar log. So the solar log can measure the complete production and then regulate the PV system to fill up till the regulation border till 5,000 watt. So the one generator like the wind is unregulated, and the solar log takes care that the PV system is only producing so much power that the maximum feed-in border is not raised. And you can choose the interface which is activated for the regulation. I think you can also use it in other countries if you have combined plants, or if you have an older installation and a newer installation. I think in this area you can also work with this functionality. It's available in fixed regulation in watt and also in fixed regulation in watt with self-consumption. What's new also, I told you in the agenda, the configuration and the definition of the devices. We're going to start now on the logger, and we're going to connect some devices, or I already connected some devices. And we're going to show you how we can define and detect them now. So what I got connected, it's a smart energy simulator. I can also show you this device. It's a small device. With that we can simulate the sun. We have two buttons for the production, so with each press the production goes up for 100 watt, and with each press it goes down 100 watt, and we can also change the consumption values. So inside this box there are two Janitza meters, and we're going to use them as inverter mode. Okay, then we change to the solar log. I just resetted it before. We change to English. It's a new factory resetted solar log. We are in Germany, but we speak English. Okay, then we check the time. It's important all the time that you do it if you install a new solar log. We save. And then we are directly leaded to the definition, where we can add all the devices we connected to the solar log. You might remember the old version where we had S0A, S0B, S0EA, S0B, RS485A, BC, and all the interfaces of the solar log. Now you have only the possibility to click on the plus, and you say add entry, and we say okay, we're gonna add a meter. It's a Janitza meter. It's connected on RS485A. Okay, that's it. Then we're going to add another device. This is a switch. And we take the switch from solar log, and we take a smart relay station 3 times. It's connected on Ethernet, that's clear. You cannot choose another interface because this device is only connectable via Ethernet. And I can choose the number of devices I want to connect. In this example, we keep the 1. And we add another device. We said we have to connect it also a switch from Gude the 2110 I showed you before. It's again on Ethernet and only one of these. And to finalize, we choose the internal relay of the solar lock. The relay is connected internally, and OK. So now we have all the devices defined. We save that, and then we can start the detection. Here you can find an overview of the devices you will search now, and then we're going to start. I see one question I can answer about regulation value in watts related to AC or DC. So it's the percentage. The regulation value in watt is AC, because we measure and we take care about the AC. This is important for the grid. The DC values are not so important for the grid issues. Okay, we see the detection here on the screen. I know we have connected two Janitsas. He already found these two, so I can skip this. Okay, we found everything. Okay, got it. Now we go to the configuration to define all the devices. As I said, with the Smart Energy Simulator, we found two Janitsa. These are the inverter 1 and 2 Janitsa, and we have to put the first one as a generator. Here you can also see one new thing of the firmware. Before it was like inverter mode. Now you can choose generator, and now you can choose also the energy type of the generator. So you can choose photovoltaic or CHP, as a combined heat and power plant. These devices have to be measured with a meter also. But we say it's a photovoltaic. We say it's the production. And we put the power of maybe 8000 watt generator. Save this. Choose the second one, and this has to be defined as a consumption meter with maybe maximum AC power also 8000, and we put here consumption. The third device is the smart relay station, and here we have to configure the IP address. In our case it's 192.168.110 and 247. And the operating mode of the meter you can choose, because the smart relay station has some internal meter. In our example we just deactivated, and we put also the nominal power of the switched contacts, so what's connected on these switches. In our case we put here 550 watt, and the other two we switch 800 watt. And it's the relay station. Like this. Save. Next device is the Gude 2110. It's also connected on Ethernet, so it's 192, 168, 110, 100, I have to check, 86. And about the nominal power, we put maybe with all of this context we should switch 500 watt, and it's we will use it afterwards for heat pump, so we put heat pump as key ready. Ready. Okay. And the last one is the internal relay. We put maybe relay and nominal power of 300 watt. Okay. Now we have all defined all the devices. Going back to the presentation and see what examples we are going to use. Oh, first I'm going to talk again about the functionality, just to fresh it up. The solar lock is the central device, so it collects the data from the inverters and from the meters, and even also from meters working in generator mode. This is also possible. And then the solar lock can calculate the sum, or the difference between production and consumption, which is the surplus. So most of the smart energy logics are based on a surplus, because you want not to feed in the energy, the surplus. You want to keep the energy in-house and maybe use your energy as good as possible for your own needs and don't feed it in. So the solar lock now knows how much energy is available from the rooftop, and he can give this information to the smart energy control logic. This smart energy control logic is a piece of software inside the solar lock, and these are the pre-programmed logic for different applications. That was I will show you now. And this smart energy logic decides in which case the smart plug or the relay or the every switch should be turned on and off. And the smart plug does the physical switching on and off for the appliance. What you can see, there's also a back channel from the smart plug or the relay to the solar lock. So these are the intelligent plugs which can also measure the load. What we can also do in special cases, for example, if you have zero export plants. In Spain they use them a lot. You are not allowed to feed in. So per definition the surplus is zero in this case. But maybe there will be enough sun to activate something. So we take a sensor, a radiation sensor, and this sensor could, and with this sensor the solar lock could calculate a theoretical surplus which is coming from the sun, and then he can turn on and off devices based on this value, not on the real now existing surplus which is zero all the time. And new now we have some smart plugs or relays with temperature sensors, so you can also do smart energy logics based on a temperature measurement. If you're going to plan some installation, I would recommend to think first of the appliance. So what is the appliance? Is it connected with a plug, or is it connected with a cable? Is it a high load, big load? Is it only voltage-free contacts like SG-ready signals for heat pumps, or is it really a power switching device? That helps a lot to detect the right smart energy actuator. So the first example I'm going to show you, I'm going to talk about a trigger, a pool pump. You see the scheme. We have the solar lock, we have a smart plug, and we have a appliance which is the filter pump. But we can also use, for example, the smart relay station to turn on and off this device. Okay, we're gonna jump to the logger firmware, to the point configuration, smart energy. And here you can see the major changes right in front of you. Before it did not look like this. What we can see now, we have on the upper side the detected hardware. That's what we also configured, the relay station, the heat pump with SG ready. Oh, I wrote it wrong. Maybe we can change it, or we can see the current values here and all the hardware detected. And we can now create some switch groups. In these switch groups we can combine different switches from different hardware types. So we can say, okay, to turn on and off the pool pump, I will take a relay from the relay station and just drag and drop it down here to the switch group. So it builds up a new group. You can choose your name. We put maybe pool pump. And it's a consumer. I will show you the other operating mode later. So now we have defined one switch for the pool pump. What we can do with this switch, we can choose if it's on automatic, that's blue. We can turn it off permanently and we can turn it on permanently. But in most cases you will use the automatic. I think this function makes sense for seasonal changes. If you maybe have a pool pump, you use this only in summertime. So in wintertime you maybe turn it off and then it will not be included in the smart energy logic, and the solar lock can turn on and off other devices. If you stay with automatic, you can configure it here. And what you see now is the configuration possibilities. We have different categories. So we can choose surplus, we can choose production, consumption, device specific, this is more for heat pumps and heating rods, and others, they can find an automatic timer. But in most cases you will choose the surplus. So we take surplus and runtime control, because we say, okay, the pump should run at least 3 hours per day. This is needed to do all the circulation in the pool. We said it has 500 watts, so 550 watt load, so we turn on maybe at 800, and now we don't put the under surplus level, we just put a hysteresis. This could be 200, and then we see the under switching level. So this 600 shows us if we have a consumer with 550 watt that we will never run into grid consumption with this calculation. The second parameter which is used for the activation is the runtime. So we say we want to have exactly or minimum 180 minutes. So what does the solar lock do now? He's turning on and off based on this surplus values, and he's counting the time. Remember that we work with 5-minute average values, and if the device is turned on, it stays on for 5 minutes, and if it's turned off, it stays also off for at least 5 minutes. So the solar lock can count the time this device was running, and if it was running 180 minutes, nothing happens. But if not, he will start to fill up the runtime at maybe 6 or 4 o'clock in the afternoon. Here you have some additional options you can activate or not if the minimum container switch on time. So if the device was turned on once, it should run at least 15 minutes without turning off in between. For our pool pump, this is not really important. We can deactivate it. But maybe for heat pumps or for air cons or some other devices, they need this time to run, and they also need some time to relax after they have been turned off. So if it's turned off, stay off for 15 minutes. in our case we don't need it. And we can also choose a maximum switch on operations. So in this configuration the pump will be turned on and off maximally 10 times. So in our case we don't need it, but I think for some devices it makes sense, because yeah, think about the lifetime of the devices if you turn them on and off too much. We choose this, okay, then we save. So what we can do now, what you're gonna like, we can switch from here directly to a smart energy simulation. You can also take the long way, going diagnostics, smart energy simulation, but you can also use this short track to come between the simulation and the configuration. So what we do here, we can choose a production curve. We can say, okay, we got a normal irradiation and we got a normal consumption. Please start the simulation. So the solar log is now calculating how the smart energy devices will be turned on and off with this configuration under a normal production, normal consumption. And this is what you can see here. Maybe there are too much information inside now. I will clear it a little bit. So we have the production and the surplus. So with yellow you can see the production line, with green you can see the surplus, and with blue you can see the situation of the switch. So in the morning it's turned off, at 7:55 it turns on, then it goes off again. Why goes it off? If you put the consumption here, the total consumption, you can see that here is a consumption peak, and so we have no surplus. The consumption is higher than the production, so you see exactly how the solar log turns on off the device, and after the surplus is available again, the heat pump, the pool pump goes on again. And you can also see the runtime. Okay, we jump back to the configuration to add the next example. The second example will be a heat pump controlled with SG-ready signals. So these are two potential free contacts where you can send at maximum 4 informations. So we take two of these switches, just drag them, heat pump, take another one. To explain the colors, maybe what you see here, that you have some switches completely green or completely red or mixed. So in the upper level area in the left corner you can see the real, how it is, and in the upper corner, lower corner you can see how it should be. This depends on the switches. For some switches we have the feedback informations if they are turned on and off, and some not. So in the heat pump you can see it. Okay, we go to the configuration, and for the heat pump I would recommend the function heat rod 3-stage digital based on the configured nominal power. So what we do, we say if the surplus is bigger than 1 watt, we need 0.1, which means low power for the heat pump. Then we say, okay, with 1500 watt surplus, we need 0.0. This means this is the normal operating mode of the heat pump. And with 2000 watts, we want to have a 1.0. This means forced operating mode for the heat pump to heat up the boilers more. And the fourth step is not needed. In our case, the heat pump offers only these 3 stages. Okay, if you need another ones, you can just add it with the plus. So this is the heat pump example. What else is possible? I told you that there are some temperature sensors also available, so we can now do some temperature selective smart energy things. I can show you this also. This is the smart relay station. You might know it. And to this one we can connect additional temperature sensor. It's a PT1000. And yeah, here you can see the smart relay box, which is not used in our examples now, but it's installed here. Okay. Well, we want to go to the logger directly. So what we do now, we turn on and off something based on the temperature switching. And then we can also mix some contacts. We take one contact from the relay station. We put climate. And we take, for example, the internal relay. So we mix 2 different hardwares to one group. And so the SolarLock takes care that these 2 switches are operated simultaneously. This switch contact, you can also, if you put your mouse over the contacts, you can see, I hope you can see it on your screen, some small shadows showing which switch is used in which device. With the relay station, if we click on the details, we can also see the state, switched on, switched off. The measured voltage, okay, you saw it, it's not connected on the power level, but we can see also the measured temperature. Now it's 24.7 degrees centigrade. So what we do now, we will say we make a surplus and temperature control. Use the temperature sensor from the relay box and turn on, please, with 3000 watts and put a hysteresis of 300 watts, so the consumer is about 2700 watt. And then we say if the temperature is greater than plus 28, turn on for some time, or turn on till you reach a target temperature, or as another option to turn on something, turn on if you reach the minimum temperature. This we don't need, and this we don't need, and here we put maybe 5 minutes. Okay, then we save. We save the whole thing. And then we jump back in the, no, then I'm going to show you the surplus management. What you can see here, 2 settings. The first setting is on which value the logic should work. On the average values, the 5 managed values, this is what we used before. And now it's also possible to use current values. What I would not recommend to use these current values functionality together with PV generator, because the PV generator is changing so often. I would recommend to put the average values. If you are working or checking your smart energy logics, configuring it, it may make sense to put it on current values and keep it running on this setting for a few while, and afterwards you go back to the average values to get a more stable, more controllable switching operations. We keep with the average values. What you can do with the surplus offset, you can also define an offset for the smart energy logic. So if you put here maybe 50%, we have an 8000 watt generator, so the surplus calculation will start only above 4000 watts. In our case, we don't need it. In Germany, we have the 70% rule. Some customers like to feed in as most as possible and just cut the peak of the 70, just use the peak over the 70% in-house. With this functionality, you can do this. And in the area here, we have the priority list. You know this function from sorting inverters and other devices. You can just drag and drop this defined switch groups and change the priority. In our case, I think the heat pump will be most important, and then we save it. You go back to this switch group and take the short track to the simulator or to the status. I can show you here what we see here. Here you have an overview over the existing values in the solar log and the informations of the single switch groups you build. So the production is now 3,900, the consumption is 3,000, and the surplus is 900. The smart energy consumption is 0 at the moment because none of the devices is turned on. So the surplus is 900. What you see now, this surplus comes up to the first priority. And you can, if you go with the mouse on the question mark, you can see, okay, you can see the configuration. It's a heat rod 3-stage digital with 1 watt on off. That's what we have now. And so on. And you can see also which surplus is available for the other switching groups you built. For the climate, it will be turned on 3000 watt, but it has only 400, and the pool pump, it will be turned on 800 and it has only 400. But here you can also see the temperature for the climate, and if I put my hand on it, the temperature should raise. And the device will be turned on. Yeah, it's above 29 and you see both switches turned to green, so they're turned on. You might not could hear the clicking of the relays, but I heard it. Okay. The history that I cannot show you because this logger, as you saw it before, it was factory resetted. I don't have any historical data, but if you have a running system, then you can see a history in the same style like the simulation. And in the simulation, you can also choose a day. I don't have any historical data, I told you, but if you have it, you can say, okay, I configured something, please show me how would it be, or how could it have been on the 1st of March last year. Then you choose your day and he simulates defined smart energy logics with the production date of this day. But we stay with the normal irradiation, and you can also choose a consumption also from a day. But please don't use the chosen day for both, because if you choose it for both, the consumption and the smart energy consumption will be overloaded and then you get some errors. So for the simulation, please use only one of the two values with the real data. We take a normal consumption and start the simulation. So now you can see the simulation results. Here you have the heat pump. It's running 0, 0, 0, 1, 1, 0, all the time changing. Here you have the climate with the surplus, priority to 2. You can see it's turning on and off, from on to off, off to on. You can see also the runtime, and the history is just the same. It has the same style like the simulation. So as a last example, what we can do, I will show you the possibility to turn on and off a CHP, combined heat and power plant. So we put CHP and then we choose the operating mode generator. We continue, and if we have a look to the automatics now, we have some other categories, for example grid purchases. So we can say if the grid purchases is bigger than maybe 200 watt, turn on the CHP. Now we have to define how big is the CHP. It's the contact 3 of the SG ready heat pump switch. So we put, maybe we save here, and now we have to define at the switch which is the nominal power of this switch. We go back to devices, configuration, we choose the heat pump, and then we can say we use this contact. This contact will activate a CHP with 2500 watts. Small one, very small one. We saved it, and then we can go to diagnostics, smart energy. This is the same place where we have been before with the short track. And then we can start a simulation with normal irradiation and normal consumption, and then we can see how the CHP is turned off and it will produce energy. And this, with the CHP produced energy, can also be used for additional smart energy logics. With this configuration, you can also do some peak shaving. For example, if you say the consumption, if the consumption is higher than 10 kilowatt, turn on the CHP. Then you have an additional generator in your for your self-consumption, and you don't need to take such high loads from the grid. This can save a lot of money in a lot of installations if you do peak shaving. Load peak shaving, not production peak shaving. So here you can see it already. I will show you just to take some things away. Here you can see the total production. Here you can see the CHP, and then CHP and PV. Then the day through the PV, and in the evening and the night the CHP comes back and produce energy. So the 0 is here. These are the 2500 watt coming from the CHP, and here it's mixed. And you can see also, if we go down to the CHP, when is it turned on and off, maybe take away these values, so you can see it's on, producing 2000, turn off, jumping back to the PV production, turning on. You remember this small peak we had before, where the consumption peak comes up, then in this case the CHP jumps in to produce some energy. I think you will find some good applications for all these examples, and we will be happy to hear from you what you do with these options. Yeah, if you have some cool installations, some tricky things, would be nice from you if you share it with us, and we can share it with the other with the other SolarLock users or installers. Okay, then we go back to the presentation. I talked about the energy flow on the display, that it's available, and just the last slides, there's a further few functionalities and the lookout. With the new firmware, there have also been some optimizations in the area of the FTP export. If you transfer data through slow connections like analog modem or GSM router, we implemented some longer waiting periods. And for the sensor boxes, the manufacturer of these devices has improved the exactness and with the same price or constant price, so we have a better feature also with this. Look out what will come up with the next firmwares, what we are working on. So there are additional heat pumps available. Stiebel Eltron is just in the pipeline, they are testing on it. And also charging stations from Keba, the P20 and the P30. There we are in the final tests. So with the next firmware, these devices would be integrated to the SolarLock. So that was from my side. If there are any questions or any things you want to see additionally, I can show you. Please write to Martin. If not, he will be there for your questions, maybe more than 10 minutes. And we will send you also some information after the webinar. We have one document we're going to share with you. It's a smart energy application manual. It's just in the translation now, so in the next days you will find this in your post or in your mailbox. And there you can find the description of all the functionalities and the examples and even more examples, and you can also find some diagrams, some wiring diagram examples where we have to put the meter, where we have to put the inverter, how to connect everything properly. Okay, then thank you very much for your attention, and yes, see you.